Hello everyone, my name is Thiago, and on this video we're going to build a complete API from scratch in Go. So if this is your first time and you already have some knowledge of Go and you want to start building backend projects, I'm going to give you this project as a starting point. I think it's a perfect project to build. This is going to be an e-commerce application. We're going to build this whole API from scratch, and I'm going to simulate it like I would be like on an interview. This way I can show you my whole thought process, my decisions, the architecture we're going to do, and then we're going to actually build this whole API from scratch. My goal is that by the end of this video you have the needed knowledge for you to build your own projects, and then from there actually learn the other topics that make building backend projects altogether, right? I have on my channel already the backend engineering course with Go. This is the perfect next step after this video, so check out the first link in the description if you are interested. Alright, so before we actually get started, let's get some common ground into what you should know, the goals, and then the assumptions that I'm gonna make to build this project. So this would be like this initial phase on an interview where you are discussing with the interviewer what you're gonna build, kind of the goals, and setting some boundaries for the whole project, right? So because this is a video, I'm going to show you what are the prerequisites that you actually need. You need, of course, some basic knowledge of Go. Just the syntax is fine, honestly. Go to the official Go documentation and do it. It's pretty easy and nice to do that. And then I also mentioned some concurrency. Although we're not going to use concurrent, we're not going to write concurrent code, behind the scenes, building a web server, which means building an API, it's already concurrent. So when you make a request to a server, this is going to be a concurrent request. And just knowing that this is a thing already gets you so far. So check out my other videos I have. For example, the latest video I actually made is concurrency crash course. So it's a very nice starting point if you struggle there. And then I would say again, as I mentioned on the intro, check the complete backend engineering course in Go after this video if you still want to get into some more details, because as I'm going to mention here, we're not going to do some of the things that a complete API would have. For example, authentication. We don't have time to build a complete and robust authentication on this video. I didn't want to make a half-assed authentication just to have it covered. I already covered it in my channel and on that video as well. So if this is something you want to do after this project, I think that is something very worth pursuing. So this is pretty much what I have on these points. So with the prerequisites done, let's actually define some goals. What are we going to do? We're going to build a public API. And really what this means is that we're going to build an API ready for other people to use. This means that we're going to make it RESTful. It's going to be stateful. And this means that we are just going to follow some standards set by more intelligent people than me. For example, Royal Fielding. So this is a paper, a very known paper that most of us build upon it and we don't know it. This is what it means to build a RESTful API. You don't need to read this, of course. It's just kind of an agreement that everyone has when building production APIs. You're just going to do it by heart. You're not even need to know what's in here. I'm going to leave this resource on the description, by the way, if you want to research more. I also covered this on the backend engineering, but another paper that I like, or project, it's the 12-factor apps. So this is kind of outdated, but I still think this is very valuable in today's world because it's kind of 12 principles that you should follow to build good, reusable projects, especially APIs. For example, we're going to have a code base that's going to be used with version control, for example, Git. We're going to have explicitly dependencies that we're going to declare and inject. So we're going to use dependency injection on this video. We're going to configure our environment from variables. So everything that we're going to add on our environment is going to be from variables, which means that it's going to be reproducible on other environments that you might deploy. We're going to treat logs. So we're going to actually use structured logging. So I'm going to already teach you what structured logging is, which is pretty good, and I don't see that online much. So let's actually go back to the diagram. And then it needs to scale later on. So we're going to build it in a way that of course we can scale. Let's get to that in a bit. And then assumptions. So I have already covered this pretty much. I'm going to tackle this like an interview, and then we're not gonna add authentication because I have other videos doing that, and then just doing authentication and building a robust API on just one video, it's too much, I think. So yeah, let's get to actually architecture and the design decisions that we're gonna have. This is gonna be somewhat simple, but it's important that you understand, again, this is a starting point video, so it's not that complex, but the idea is that we're gonna have kind of the flow, the initial flow. So we're going to have a user, right? And the user is going to make a request. For example, we're going to have a web application, we're going to have a desktop app, and these desktop apps could be, for example, built with React, HTML, or CSS. They are going to communicate to a server, and this server is going to be the actual API. Let me actually get some diagram icons that I have access to here. So, for example, this is going to be our API server, okay, and this is just going to be one instance. And why I'm saying that is that this is how we're going to actually scale. So if you have too much requests, what you can easily do is just scale it vertically by creating multiple instances. This could be virtual machines, or could be just serverless instances like Cloud Run that you can just spin up automatically based on traffic. So most cloud providers already do that for us, so I'm not going to worry too much about that. I'm just going to say that this is how you could scale initially. And then we're going to have to store orders. So again, we're building an e-commerce. I have not mentioned this too much, but we're going to build an e-commerce application. And this means that our domain is going to be products and orders. So we're just going to focus on these two resources. So we're going to need to store these guys somewhere. So I'm going to actually write here a database. So nothing fancy. Actually, it's not this icon that I want. So let me get this one here. There we go. Okay, so this is going to be like a Postgres database that you're going to just store our data. For this business domain, I like to go with a relational database like Postgres. You could go, for example, with a document like MongoDB, which is fine as well. But I prefer to go with relational database because we can actually model it better, for example, for this interview. And this is exactly what I'm going to do right now. So as I said, we're going to work with products and orders. We could, for example, have users, which is going to be like the customer. We could have stock items. We could have other entities, but I'm just going to reduce the scope for what we are actually going to build. Okay, so let's actually start defining kind of the database table schema for this. I'm going to start with the product. So the product is going to be like the item that you would go, for example, to Amazon, and there are going to be items, products, and this is going to have an ID. It's going to have, for example, a name, a price, and I'm going to actually say price in cents so that we know for sure what is the kind of the currency. I'm going to use cents because you can easily convert it to dollars, to euros. It's kind of universal. And then we're going to have the quantity of the product. So this is kind of our initial stock. If we were going to scale this into a bigger application, in the future, we can move the stock out of here into its own table called stock. Why? Because if we're going to be updating stock, we're going to always be changing the products table. This is not a good design because, as we're going to see, once we get into transactions and kind of this ACID design, there's a design of good principles for building databases and designing databases. We want to have it their own database table for the stock instead of having inside of the product. And if you're going to always be decreasing the quantity here, it means that we're going to have to always fetch the products. And then this means that other endpoints that might be, for example, listing the product, changing the price or something like that, they're always going to be changing the quantity here. I think it's fine to start like this. It's fine to start like this. And then in the future, we can write a migration to actually move the quantity to the stock, maybe its own service. And then we're going to get into microservice architecture. But I think this is a pretty good starting point. Okay. And then for the orders, this is going to be the idea that a user is going to place an order, and then he is going to have the items, so the products, of this order. But for this, we need to have kind of the order or the parent identity for the order items. And I have already said that the next table is going to be orders items, okay, or just order items. This is going to be the way we're going to relate orders or an order to multiple products. This is how we usually do it in relational database, is that you create a join column or a join table to have both the items or the products. You could actually call this order products. I'm going to call another column called customer ID. So this is going to be the user ID that made the orders. If you have authentication, this is going to be the ID of your user. For us, it's just going to be some random numbers that we're going to use for tracking for now. And then we're going to have a created ads and maybe a status column. For example, order created, order had an error. What is the status of the order? Has it been paid, for example? So this is good or an important status to have. And then the created ads just for tracking when was this order created. Last but not least, let's actually finish the order items, because this is going to be a join table. It means that it's going to have the product ID, and then the order ID has a composite primary key. So this is how we're going to create unique entries for this table. And then last but not least, we're going to have the quantity, and we're going to also have the price. Why are we including the price? So we can actually call this price instance as well. Why are we including the price on an order item? Because the quantity makes sense. You want to order, for example, 2 bags of potatoes, but you want to also add the price here, because if you bought this item at a discounted price, you want to store it at that price that you bought it, okay? If you want, you could actually add the total price, which means it's the quantity times the price. That would work. I prefer to keep things more atomic, and so I'm just going to add the quantity, the price in cents, and then, for example, when you fetch an order, you could, for example, just calculate that on the fly. That would be a good solution as well. Okay, so this is pretty much kind of the schema. There's no right or wrong solution for this. This is the one I'm going to go with. The most important thing is that you can articulate this, build it, and then defend your solution. And this is what I would do on an interview if I were asked this problem. Now, we're still not done with defining the architecture, because we still need to define the high-level design of the API, so the actual customer-facing API that the users are going to use, or our frontends. And for this, I'm going to just define some endpoints. So this is kind of where the RESTful principles designing comes in, because we're going to use the HTTP methods, and then we're going to define the handlers or the endpoints strings as resources in our database. So let me go with you again. We're going to build these endpoints, right? And this is like the very simplest one. For example, just a health check. So this is going to check if our API is healthy, pretty standard. And then we're going to build, for example, these endpoints, which is going to get. So this is a get method on HTTP. So there's get, posts, patch, puts, delete, and whatever action we're going to do to our API, we're going to use these methods. For example, if you want to delete an order, we're going to do delete and then the slash orders, and then we're going to pass an ID of an order. If you want to update an order, you're going to use the patch, and then you're going to do the same, because you're going to update this resource by this ID. Pretty easy way to define an API, and this is how you'd go about defining a public-facing API that other engineers are going to integrate maybe in the future with your products. And then we're going to also build the post orders. So we're just going to build these 3 endpoints, something around this. We're going to create this, which is going to be the most important. This is how we're going to place an order. I have defined here kind of how we're going to solve this problem, because there's some thinking we need to do there. And then there's the get products, which is just a list. And then if we have time, we're going to add some pagination and some filtering by name if we have time for that. And then as an exercise, I'm going to, throughout this video, I'm going to show you or propose to you some exercises for you to do. Some of them are going to be endpoints that you can do at the end of the course. For example, how to get an order by ID. So you're going to implement this from scratch. And then we're going to do how to create a product. So we're going to manually create products on the database But if you want, you can create this endpoint to actually create products yourself. Okay, so I said that placing an order has some thinking to do, and it does. How are we going to define this? We can actually come back to this once we get there, because let's actually start coding. We already have a pretty good architecture. Let's actually get started. I'm going to create an empty Go project, and then I'm going to see you there. Now that we know what we're going to build, we can actually start coding it. And the first thing is that I have just created a folder for this project, and I'm going to do a Go mod in it. And then I'm going to do my GitHub handle, and then the name of the project. I'm just going to call it Ecom. This is how you create a Go package, basically. And with this Go package, you're going to be able to install older packages. So this is the reason we're doing this, as well as to define the Go version we are using. Again, it's not that important which version you have, as long as it's above 122. Even then, I think it's even fine if you go lower, because we're going to use most, instead of just using the standard library with Go, like I usually do, I'm going to install some lightweight packages to handle, for example, the HTTP server, all of that. I'm going to use Chi, which is a package to handle routing. And I really like Chi because, as you're going to see, you're going to be able to do some middleware composition, and as well as, I think it makes the code way cleaner if you're building APIs. Now let's create two very important folders, which are very standard in Go projects. So it's important to show you, once you're reading other projects from other people, this is basically kind of a standard, right? So there's a CMD folder. This is usually where we contain executables. You might actually see another folder inside, for example, for the API, another one for the CLI. If this project has a CLI tool, you get the point. Another one is called the internal. This is also a very important name in Go, because this is actually kind of a reserved folder. This folder does not export. So for example, imagine that, let me just show you here, that this is our project, Ecom. This is a package. So everything in Go is kind of a package, very similar to Java. And then if someone imports your project for some reason, I don't know, like package to something like that. So someone is going to import your package, they cannot have access to this internal. So this is kind of, I know most people are not going to use this feature, but it is standard, and that's the most important part for me. It's a standard. So if you have that standardized, you can switch to another project and it's going to be the same. I'm going to create two files inside of CMD. One is the main.go. This is indeed the entry point, and this has to be inside of package main. And then I'm going to create another one, which is something that I personally like to do, as well as inside package main. Let me explain to you why I like to create these two files. I know that some people might actually disagree, but the main.go, and because I like to use dependency injection, meaning that I like to work with dependencies, which makes the code more testable. Go is such a nice language to do that, because it's so easy to create a dependency or to create an interface and create more concrete implementations, I should say. And so I like to use this file to compose dependencies and call the program. So basically start the API. And then here on this file, I like to actually define the API start and the handlers, basically meaning the API signature. So anyone coming to this project can just click on this file and he knows all of the endpoints. That's kind of my go-to structure. I'm going to create a main file or a main function. So this is indeed the entry point of the whole program. And yeah, this is as simple as you can go. And then inside of the internal, we're going to have all of our other packages that we're going to create, and then other packages that we're going to have code being created. Let's get that into a bit, because we're going to use a package later on by the end of the video called sqlc. This is how we're going to actually write queries in SQL, and then they are going to be generated into Go codes. Pretty neat. Okay, so let's focus on building our HTTP server, and then we can start actually working on the rest of the program. So I usually like to go to API and create two very important structs. So the first one is the application. You could also call this API if you want. I like to make it a bit more generic. And then another one, which is going to be the config. Okay, so the application is basically kind of a global struct. This is what your API is going to have. It's going to have methods that are going to run and mount your API. So it's going to mount. So this means that it's going to create all of the handlers, all of the endpoint signatures, for example, that get orders. We're going to compose everything here, and then we're just going to have a run, which we can just use to start our server. If you're getting fancier, you can actually add graceful shutdown as well. This is where I like to basically add it. It's just a function that you can compose your HTTP server more in detail. Okay, so on the application, one of the dependencies is actually the config. The config has stuff such as the address. So the address is the address of the server, for example, port 8080. Again, this is kind of referring to that 12-factor document, which our application needs to be composable from configuration. If we're going to deploy this to production, we need to pass a different address, maybe a different port as well, then to development, and so on and so on. Okay. And last but not least, I'm going to add the DB configuration. So I'm going to create another struct called DB config. I'm going to create it down below. And this is just going to have the configuration that we're going to use to configure our database. I'm just going to use something very simple, which is called DSN. So this is kind of a domain string, kind of a string that you're going to use to connect to the database. It's going to have the username, the passwords, the database name, all of that. So we're going to get to this once we get to that module. For now, let's just get our config, save it here. And as you can see, this is our application for now. Later on, we're going to also have logger. The logger is going to be a dependency if you want. I usually like to make the logger a global variable. I'm going to show you how to do that as well, but just to know that you can actually put the logger as a dependency. It's very common as well. And then you're going to have the actual DB driver here. So this is going to be kind of our main global dependency that we can inject or not for the tests. This is where it shines, the dependency injection, because you can inject dependencies for each environment that you have. I'm just going to save this file. I'm going to come here to main, and let's actually just create an initialization of our struct called application, or actually, sorry, the config. I'm going to start with the config because you need the config for your app, which I'm going to just call API. This is the type of application. And here you're just going to send your config, which is going to be CFG for short. And actually, we don't need these pointer things here, just kind of habit of my own. The first thing we can actually configure is going to be the address. So we need an address to run an HTTP server. I'm just going to put 2 dots in 8080. So we're going to run at the 8080 ports. And then the database configuration, we can actually just leave it empty. I'm going to leave it like so. And this is pretty much it. I'm going to save it. What we're going to do now is actually write the run and the mount functions for this struct. The way you do that in Go is that you just do function, and then I'm going to call, for example, app. I'm going to make this an application. This is actually going to be a pointer method. And then I'm going to call mount. It is going to return an http.handler. Very important. I'm going to save this file to import it. I think if you have VS Code or Cursor, this is going to be the default behavior. And very important, http.handler is agnostic. This means that any package that you import, for example, you have Gorilla Max. This is one package for handling HTTP servers. You have She, you have Fiber, all of these packages. The way, if you do this, it means that those packages 100% import this interface, they implement this interface. So I like to keep it this method agnostic. Everything you do inside here, it doesn't matter because you can use Fiber, you can use She, whatever you want, it's going to work. And this is how I like to make my apps, a bit more agnostic, and then you add the details inside as you like, okay? So I'm just going to call chi.newRouter. Okay, I'm gonna call this function, I'm gonna import it, and you can see that it automatically imports. But if we click on this package, let's actually see the documentation. You can see that this package has a highest tag version called v5. So if you click here, you can see this is actually the package we want, which is the v5. So we have to prefix this v5 version with She. And since we're here, let me actually just copy like everything they have here. I'm gonna actually just copy this from the documentation. No shame in that. Let's just prefix this v5. And then just below the mount, I'm gonna actually just put this here. I'm gonna save. And we need to actually import our package. So go get package, you can write this command, or you can just right click on your VS Code, and what I'm doing is that I'm doing commands dot, and I can just do this. This is going to import, and here you have your Go mod with the package imported. Okay, now that we don't have pretty much any errors, I mean, we still have, because we have to return the router from our signature, like so, because I'm expecting this. This is going to make sense once we go to the main, because what I'm going to do is that I'm going to mount and then run the package or the application at the same time. I'm going to show you what that means. For now, we can actually comment this out, because this is going to be the part that is going to be on the run, because this actually listens and serves. So this is running the server. And then we can actually, this is important, this is the router. These are middlewares. And actually, I wasn't expecting them to just show me two. If we actually go to the documentation, I think they have a better documentation somewhere. Where is it? Let me actually get to their GitHub, because this is different. I'm going to click here. Let me increase here the font for you guys. So you can see this is the official package, Goshi. And if you scroll down below, I think they have a better documentation. Where is it? Yeah, this one. This is exactly what I want, because this shows how you can actually kind of do a RESTify or a REST route for your articles resource. So this is exactly why I like She, because you can route everything inside of this constructor, and then all of the other handlers are going to implement or at least inherit this string. So it's going to be articles/search, for example. And if you have ever written an API with just Go or the NetHTTP Go standard library, then you know that this is pretty interesting to have. And so yeah, this is kind of the way I'm going to do it. Let me just copy it again. So the router, and then this stack of middlewares, these contexts, and then just the get, kind of a health check we're going to use for ourselves. And I'm going to replace this guy here. I'm going to save to import time package. There we go. I think I'm going to decrease, a bit the fonts, because I think it's a bit too big. So yeah, let me explain to you what this means. I really like She, because it also has a very good middleware package where you can just call middleware and a couple of middlewares they implement themselves. So the first one is the request ID. This guy is very important for rate limiting. So if you're building a production API, you need to have rate limiting at some sorts. Basically you have to have some sort of rate limiting. It's very important if you don't want to get DDoS or something like that. Then the real IP is also important for rate limiting, as well as analytics and tracing. Okay, so this is kind of the real IP parsing. You can actually click this function and see what they do. They basically handle this whole parsing of the IP of the user. And this request ID basically does something similar, but it creates a random ID for each request. How does this work? This is going to add this ID to context, and every handler we're gonna pass the context, so the Golang context package. And this is where we're gonna pass our request ID. This means that we can have tracing. For example, a request comes in from a user, it's gonna hit your handler for get, I don't know, products, and then the product is gonna call the service, which is gonna get the get products function, and then it's going to go to the repository or to the database, which is gonna actually do a select all from products. So this is kind of the usual flow of the clean layered architecture. And you can actually pass the whole request ID along all of these calls. If something fails here, we can throw an error with the request ID. Okay, so just to give you kind of an idea of why you want to have that. A logger is kind of a pretty logger, I should say. You're going to see once we start the program, it has colors, it has all of that. I like to keep it. It's optional though. And the recover, it's nice to recover from crashes, okay? And then they also add kind of a 60-second timer. It's kind of a timeout. It means that if the request takes more than this is going to kind of stop the process. It's going to throw a signal with the ctx.done, okay? And this is how you actually define a route. So this is a get method. So you can see all of the HTTP methods. So delete, patch, all of that, it's all here. This means that you can actually create a pretty declarative API with require router.get. This could be, for example, /health. This is one of the ones we have defined on our specification. So as you can see, we're going to build our health endpoint, and this is it. We're going to just return all good for now. And yeah, this is pretty much it for the mount. Of course, we're going to create all sorts of handlers here. We're going to create the listing of the orders, or I should say the listing of the products and the creation of the orders. So they are going to be defined here. But now let's actually focus our attention to the run function. Again, this is going to be a method of the application struct. It is going to be called run, and it's going to return or not an error. And one thing let me do is I like to have all of these configurations down below, like so. There we go. They don't need to be on top. So I like to open the file, just see the mount. Let me remove these comments and the run as well. Okay, so the run is going to basically do this. I'm just going to delete this. And it's also going to receive the mount http.handlers. So let me just say http.handler. Okay, so I'm using a short variable for this because in Go it's kind of a standard as well. Because why would you call this handler? Because you already have here the type, you know that this is a handler. It's kind of duplicating. I sometimes like to have very descriptive names, but it's only for things that matter. Here you can actually just look at this and this is a handler, okay? This is why in Go we usually start with very small names. Okay, so here I would usually write a graceful shutdown script, but since we're kind of at the beginner stage, I'm just going to create a very simple start, listen, and serve like we had. But I'm going to go a bit more deep. I'm going to create an http.server. So this is a struct that you can configure your server a bit more in detail. So you can actually select the address. So this is something that we're going to do from configuration. So we're going to select the app.config.address. So this is going to come from the configuration that we have defined here. So you can see kind of the beauty of this. We can access this from the main.go here because this is a configuration of our app, of our API. And then we need to have a handler, which is just going to pass the handler from the arguments. And then this is kind of the optional configuration that you might want, for example, the write timeout. I usually configure this to 30 seconds, but this could also come from configuration like this. But for simplicity, I'm just going to keep it like so. Because we're not going to even touch this on this project. And for example, the idle timeout, you can also configure kind of the time.seconds, or actually, I'm just going to make this a minute. You can do that. So instead of multiplying by 60, you can just do this. Okay. So this is configuration. You can just hover over it. You can see what this means. I'm going to move forward so that we have time for everything. What I'm going to do here is that I'm just going to call this server dot listen and serve, and this is going to do the serving by itself. If you remember from before, we were actually passing the port and all of that. Because we have the address configured here, Go knows that the server is going to listen at this address here. Okay, so this is pretty much the structure. I also like to have here some logging. So I'm going to use the log package from Go, and I'm just going to say print line. And what you can do here is that, I don't know, server has started, or actually, let me do a print f. I'm going to show you how to pass arguments here. So server has started at address. You pass here a wildcard for the string, and then this is going to be our string, the app.config.address. Okay, let's save this. Let's go back to the main.go and let's orchestrate our API to run. Again, what we need to do is just mount our API, so we can actually do api.mount, and then you actually need to do api.run. Now the way this works is that this returns our handler, our HTTP handler, which you pass into the run, or if you want to get fancy, you can actually just do this all in one line. So you can do mount, and then you put an argument, or actually it's the inverse, you call the run, and then the argument is going to be the mount. And for me, this is kind of rule of thumb. When you can make like functions composable has this, it means that you're actually making kind of a good software. At least it's kind of a good metric that I like to keep for myself. If things are composable like this, you can just pass them around like the Unix philosophy. I think this is a pretty good sign, okay? What we can do is that this is going to return an error, if you know, right? And this is an error that I think it's important to handle. It's very rare that you're going to have one, but if the server, for example, the database fails to connect, it's here that you're going to know. So I'm going to do an inline error in Go. Oops, I opened here the chat. Let me close that, because we ain't going to use AI for this. And here what I'm going to do is I'm going to call this package OS from the standard library, and we can just exit our program like so, okay? What we can also do is log it. So I'm going to do a print line and say server has failed to start. And here I'm going to just pass along the error like so. And actually this needs to be a printf so that you can actually do this. And yeah, this is pretty much it, how you can create a server in Go as little as it is. And I think this is already such a production grade, you could say, way of creating a server. So let's actually run it and see if it works. So I'm going to do a go run. I'm going to go inside of the CMD folder, and then I'm going to select everything.go. Okay, so it's going to kind of compile everything inside of here. So you can see that we got this log, server has started, and then we don't have anything. This means that it's listening for requests, and it's not going to exit the program, because this is how a server works. Let's actually see if it indeed is listening. What we can do is use the Unix tool called curl. This is going to make a curl request or an HTTP request to your server. You can actually use a tool like Postman, which we're going to use later on to make requests on an interface. But for now, this tool is more than enough. So we can just do HTTP localhost 8080. This is the port we are running. And then just /health, for example. You can see we are getting the result of our all good from the health check. If we, for example, enter something that it doesn't exist, we're going to get by default a 4 of 4, because the package we're using, she already handles that for us. Now, if you go back to your server that is running on a terminal, you can actually see all of these logs here. You can see that the server has started, as you saw, and then this is actually the logger that we have initialized here on this middleware. You can see it's kind of pretty. You can see the colors, the kind of status, how much time it took, the handler, the protocol of the HTTP, all of that you can see. Of course, you can omit this or even pass your own logger. And since we're talking about loggers, let me introduce you to the idea of structured logging. And I talk more about this on the backend engineering course, but basically what you can do without installing any package is use a package from Go called slog, which means structured logging. And this is pretty nice because you can have structured logging for free, which basically means that you're going to log instead of just a string, but has an object that you can actually filter on the cloud, for example, for errors. For example, this is let me see if they have an example. Yeah, for example, this, you can see that this is the time of the log, the level of the log, which means you can filter by all of the logs that had error, because error is a level, or you can log or filter all of the logs by the info. This means that you can have a more powerful logging solution, and you can also add metadata like this. So what I'm going to do is that, as I said, I like to have a global logger so that I don't have to pass this dependency around. So I'm going to use this slog.setDefault in our program. So let me just paste this, and this logger here is going to be a logger that we're going to define. So let's define here the logger. I'm going to actually do like so, logger slog.new, and then I'm going to define the slog.handler, which is going to be slog.new text handler. So you can use a JSON handler. I'm just going to keep a text just for now, and then I'm going to use the os.standard output. And for the options, I'm just going to keep it nil. I don't need any options. And if we just save this, restart our API, you're going to be able to see that our logs are like that one I showed you from the documentation. This is a property, the message, the level, and the time. Now, what we can do with this logger now is actually we can come here and do, for example, slog.error, right? And then we can actually say server failed to start. I'm going to send another property called error. So this is that metadata. I'm going to pass here the error. So I think it's more declarative doing this way. And do you want to see this error happening? Let me actually create another instance of this API at the same port. So I'm going to do this. And you're going to be able to see that the level now is an error instead of the info. Pretty useful later on as you scale. Okay, with logging done, let's move into the fun stuff. Let's actually create our first service. We're going to create a service inside of the internal package. So I'm going to just create a folder called, let's actually start with the products. I think this is a nice start. I'm going to call this products. And here we're going to have two files for now, which is going to be the service.go. And then, for example, the handlers.go. Everything is going to be inside of the package products. Just like so. Before we actually write any code, let me explain to you what this actually means. So I like to use what I usually teach in my channel, which is a clean layered architecture. I'm not sure if I made this word or not, but this is, let me actually keep it here, clean layered architecture, which basically means it's the kind of the famous clean architecture from Uncle Bob, kind of made it into a different twist. Basically, I always keep the same structure, which is the handlers. This is kind of the transport layer. Basically, what we have just built here, the API inside of this folder is everything related to transport. This is basically HTTP code all over. This is how we're going to define our transport with HTTP. And then there's another package or another level. This is kind of an onion. You can think about that, which is going to be the service layer. The service is going to have all related to business logic. It doesn't know anything about the service. This could be running on HTTP, gRPC, whatever. The service doesn't care and doesn't know about whomever is calling it. And again, this is kind of an hierarchy because transport is going to use the service as a dependency, and services are going to receive as a dependency repositories. So this is kind of the data layer or the repository layer. Okay, this is how I usually like to structure all APIs. There's no magic. This is pretty much all of the structures I have used. You can just use this one and it's going to work for all APIs projects. And honestly, if you build a CLI tool, if you build anything like that, and if you take this mentality, it's going to work, because if you create your application layered like this, it means that you can inject everything has dependencies, everything fits like Lego blocks. For example, the repository is going to be used inside of the service. So the service is going to take a repository has a dependency. And for example, the transport is going to take all of this as a dependency. So it's kind of huge, but you get the point what I'm trying to say, I think. So yeah, this is how we're going to have the repository. As I was saying, it's where we're going to have everything related to database like SQL. This is where we're going to write our SQL. And then this is how we're going to communicate or compose our SQL. For example, if you're going to write a transaction, you're going to call the get orders and then the get order items. Like all of this is going to be composed here. This is going to basically say http.serve, http. Blah, blah, blah. You get the points. And this is just going to write your SQL queries. Okay, so pretty easy to understand into layers. And this is how we're going to build this folder. So this is the handlers, which basically is the place we're going to use HTTP. Okay, and then we're going to have the service. And I don't have here the repository. You could have, for example, repository. I don't have it here because we're going to take a different approach using a package that is going to write this code for us. Pretty cool, because we're just going to write SQL. I really like to write SQL. And if you're a backend engineer, you need to get comfortable writing it. Instead of using an ORM, I like to use SQL and then generate code from that. Okay, so let's actually start with the handlers. It's the topmost layer. Here, I like to create a struct. Again, I like to have everything has a struct because this means that I can add methods to it. This is going to receive a service, as we're going to see in a bit. It doesn't exist yet. It's here. We can actually just come here and type it out a service, which is going to be an interface. By the way, it's going to be an interface, which means that we can create multiple concrete implementations of the service, one for the API, another one like an in-memory service for the testing layer. With the handler created, I'm going to create a constructor, which basically means that it's just a function that we're going to call in our main.go file, or actually on the api.go, that is going to create this handler. So I'm going to call new handler. It's going to receive a service, which is going to be the dependency. This is how you do dependency injection. It's going to be here. This is going to return a pointer to handler, and it's just going to return kind of our implementation of a handler. So I'm going to keep this as a pointer because we're returning a pointer. And then the service, just add it has a dependency like so. Because this is an interface, you can pass any service you want. Now moving on to our first method, it's going to be very similar to what we did. So it's going to be a handler. It's going to be a function of this handler struct, I should say. Just like so. This is how you make a method in Go. And this is not going to be any handler. This is going to be the list product handler. So this is going to be our first endpoint that we're going to make. It's going to be this guy right here, the get. Where is it? This guy, the get products. Let me actually remove these drawings I did. There we go. So let's start. We have already done this guy. So this is done. Let's now start working on these get products. And here we're going to have two things inside of this function. So we're going to have one which is going to call this service to actually list the products. So this is going to call this service. The service is going to go to the database, or in this case, it's going to call the repository of the products, which is going to return products. And then we're going to have products here. So that's the first thing. And the second and last is actually just return JSON in an HTTP response. Okay, how do we do that? It's by one of these arguments. It's going to be a writer, which is the HTTP.response writer. The second one is going to be a request. So it's going to be a pointer to HTTP.request. So this is the HTTP handler signature, very important. If you don't have this here, it would give you an error when you initialize it. For example, let me actually come here. I'm going to do a router.get. The signature is going to be products. And then the handler, let me actually initialize it here. So products handler, or just products handler. And then I'm going to do products.new handler. So I'm importing this package from our internal project. So from our package, and then /internal/products. This is the package we have just defined. And this is our dependency, which is the service. But if I just pass it nil, you can actually just call to show you that you can do post handler.list products. But if you were to not include the HTTP handler here, you're going to see that you're going to have a nice error here saying, hey, this is not compatible with HTTP handler func. What is an HTTP handler func? If you click on get, it's basically this handler signature. If you click on it again, this is where my response writer and HTTP request came from. It's from this guy. One of the most important functions in Go, it's this one, the handler func. Okay, since we are here, let's actually start building things gradually. I like to have very short feedback loops. This is kind of how I build software in companies. So let's actually kind of apply that to software engineering as well. So instead of just going to the service, coding the service, let's actually just get the response of this handler. Since we already hooked it up here on the API.go, let's actually just return something to the user, right? Let me just teach you how to do that. So the most basic way is that you're going to use the JSON package from Go. This is an important package from the standard library that you can use to write JSON. So we're building a JSON API. We're going to return a JSON from the new encoder. So we're going to encode something. What is the IO writer? It's going to be our writer. So the HTTP writer, we're going to pass it in the JSON encoder. If this does not make sense, it's fine. You don't need to actually understand it. You mean, you just need to know that this is how you can actually run or return JSON from your HTTP handler. You don't need to actually just understand. And if you want to understand, you can just click on the definition, go inside it, navigate the documentations, and this is how you can honestly learn Go, because just go to the documentations, learn. This is something kind of lost with today's world with AI, so it's pretty fun. But yeah, I'm kind of digressing. Let's return something. I'm going to return the encodes, and here you can actually, for example, let's return the products, and this is just going to be an empty slice. Okay, I'm just going to create an empty slice of, I don't know, strings, and let's say, for example, hello, and then another string called world, and we're going to encode this object, this slice, and we're going to return into these. Okay, so this is where I'm going to, for example, use Postman. So let me first actually restart my API to compile it again. I'm going to run it again. Let's see if it don't have any errors. We don't. So with that out of the way, let me open my Postman. So this is Postman, a tool I like to use to make HTTP requests on a UI. It's pretty powerful, so if you want to go ahead, download it if you don't have it already, or you can just use the good old curl like we did. So let's make a request to the HTTP. Let me actually increase the font here for you guys. And I'm going to make a local host 8080. This is our server. It is at the products handler. I'm going to hit send, and this is what we get. Hello world has an array or a size. Now you can also see headers. So HTTP has headers that you can define, and headers are just metadata. One of them is the content type. This is the headers that we received from the response. These are headers from the request. Okay, let's just focus on the response headers. One of them is the length of the content, the date, and another one is the actual content type. This is important, and you can see that it's still text. That's why you don't have any JSON syntax here. But we actually want to return JSON. This is where we actually need to define our headers in the response. So let's do writer.header.set. And we're going to define the key. This is kind of a key value storage, you could say. So I'm going to define this as a content type. So it needs to be exactly like this. This is a specification type. And then I'm going to send the application /JSON has the type. I'm going to also, since we're here, I'm going to write another header called http.status OK. Okay. This is actually the status 200. If you look at it, we actually got the status 200. We can change this. For example, let's do the status created. This is the 201. So this is again part of the HTTP standard. And if you're building a RESTful API, you usually should follow these kind of codes. It's a good thing to do if you're building a public facing API. I'm going to restart my API again. Let's actually make this request again. And you can see that we got the 201, which, hey, it doesn't make sense for a get. So I'm going to revert this to an OK status before I forget. And you can also see that the content type is still text for some reason. Let me actually hit send again. Did I make something mistake here? So I figured it out. I had to kind of look it up. I was kind of confused why the header was not being set. But basically, silly little mistake. This is how it was before. We actually need to write the header before setting it for some reason, because this is a different header. I don't know, maybe this sets all of the headers to set. I actually didn't know that. I usually kind of copy paste this code. As I'm going to show you guys, I'm going to create a reusable function for this. And I basically usually just copy it, but I have just restarted the server. Let's actually see if we get JSON. There we go. We got JSON here, and the body, you can actually see that it's properly formatted as JSON. Okay, so pretty cool. Always learning as well, which is good. And one of the things I said, let's actually create a reusable package for this. Let me just go inside of the internal, make a JSON package. I'm going to create a JSON file. And here I'm going to create a function just called writes. And then I'm just going to get the contents of this. I'm going to paste it or cut it, paste it in, save to import everything. And because this is going to be agnostic of products or whatever, we're going to actually send in an http.response writer. You could even pass an IO writer instead of this guy. You could even pass this, but I'm not gonna get there. That's already making a bit too agnostic. I'm gonna send in the status because I'm mixing up status with response code. So this means that you're mostly returning from an API, which means that you're using response writer. So yeah, just kind of getting sidetracked, but the data is going to be of type any, so it could be anything. We're going to encode this data. We're going to pass in this status so that you can pass whatever status we want. And this is how you can create a reusable version of that. Now, what you should do here is that we're going to import from our own JSON, which is this one here. Very important. This is how you import it from our JSON. We're going to pass in our writer, the status, http.status, okay, and then the data, just the products for now, okay. This is how we just rewrote a reusable function that we're going to use on all of the other handlers. Okay, now that we have defined the handler, let's focus on the service, because the service is going to have, we're going to start going into the database in a bit. So let's actually start defining the signature of this service. It's just going to have one method for now, which is the list products, which is going to receive a context. So context from context. This is a very good thing to do in Go, is always pass the context as the first argument. This way you can create kind of a cascade of callings of functions, which, like I showed you before with the request ID, this is where the request ID is going to be passed from, for example. This is the only argument for now because we're just going to list all products, so no parameters needed. It is going to return some stuff, but for now, I'm just going to return an error. Later on, this is going to be a slice of products, but we don't have that defined yet, so we're going to define that with the database part that we get to reuse a function. Now, very similar to what we have done with the handlers, I'm going to create a struct, I'm going to create a constructor, and then we're going to have methods. This is exactly what we're going to do to the service, but this is going to be, instead of a handler, it's going to be a service, or an SVC for short, because we have already defined the name service here, so we need to use a different name for the struct. The dependency is going to be the repository, which we don't have it yet, so let's leave it empty. I'm going to create a new service constructor, which is going to receive later on the repo. We actually can't comment here, so let's just remember that. And then we're just going to return an implementation of this service like so. Which you can see this error here, which means that this struct does not implement the service interface because it's missing the method list products. This is very cool from Go because you know that this is how you implement interfaces from Go, is that you need to create these methods to this struct. So let's exactly do that. So I'm going to do service pointers and then I'm going to paste it in this method. I'm going to actually need to return something. So I'm going to just return nil for the errors. This needs to be SVC. There we go. We don't have an error, which means that it actually implements this interface. And yeah, let's actually, before we go to the database, let's actually initialize the service, pass it in as a dependency because currently we just have nil. So I'm going to create here the service or the products service, which is going to be products.new service. And then I'm just going to pass this dependency like so. Okay. Right now we can actually access the service on our handlers. We can actually start consuming it. Since we already did point 2, we can do the first point, which is actually just get the actual products. A possible error from handler.service.list products. We're going to pass in the context, and we actually have context from our request.context. The request itself already has the context, so we can actually get it from there. Currently, the list products does not return the products list, so we can just ignore this for now. And I'm just going to handle the error. Once that is one, we already have this handled. I'm going to do a log.print line with the error so that we can see something. And last but not least, we should return from here, as well as notify the user via our transport layer from HTTP with an error to our response writer, the actual error message, which you can just do error.error. This is kind of the stringify version of the error. And last but not least, as HTTP code, which is going to be an internal server error. It means that we messed up. That's basically what it means. The server owner messed up, and this is an error that the user should not see unless something broke on our side, which is a good error to see during development, but not a good error to see during production. So this is pretty much the whole implementation of the handler. Of course, we still need to get a product from here, which in theory, we need to also get them from the list products. And to get that, we need to get into the database part of the API. And for this part, I'm going to use a package that I really like, which is called sqlc. I have not shown it on this channel yet, but a lot of you have asked for me to use it, so I'm going to use it, which basically means that you can write SQL code like this on a file and then run a command like, let me see if they show it here, it's the sqlc generate. And basically, this tool is going to generate Go code from this SQL. You can see that they have defined here a get author. This is going to be the name of the Go function that is going to be created from this code. The same for list authors, create authors. This is going to return Go code. And this is very cool because you can actually just write your SQL code like you should, and then you're going to get Go code created for you. You never touch the Go codes. Pretty much it. You can see here that you're going to do a connection to the database. We're going to handle that as well. This is how you list the authors from the generated codes. They handle transactions, all of that. So it's a pretty good package. We're going to use it. But for now, let's actually just install it. I have already installed it. Let me show you how you can do it. If you click here on the documentation on the installed part, you can see that this is very easy to install. I'm on macOS, so I'm using the brew install. If you are on Linux, you can do this, or you can just do go install, or even using Docker. Or if you are on Windows, you can click here and install via there. By the way, if you are on Windows, I highly recommend you to install WSL for Windows. Look it up. It's kind of a Linux environment on your Windows machine. It's very good for doing development. If you're doing development, serious development, you should at least use WSL for Windows. Okay, so I have already installed this. I'm going to skip this part. And basically, we can actually just copy this syntax here. So I'm going to copy this. I'm going to go to our project. Let me stop the server. I'm going to create a new file at the root of the project called SQL. Oh, whoops, I'm not writing. sqlc.yaml. Just like so. And then I'm going to paste in the configuration from the documentation. And basically, there's not much to say here. This is kind of their syntax. This means that we are going to use the Postgres engine. We could use MySQL. This is the folder or the location of the file of our queries. So basically, these queries right here. This is the definition of our functions, basically. And then this is going to be the schema. The schema is the signature of the database we're going to use for this project. We are actually going to show this or point this to a migrations folder. Migrations are going to be like a folder where we're going to have the history of the changes to your database. Instead of just writing the creates table, the deletes table on your database directly, we're going to write files with those changes, way more declarative instead of just doing by hand. This means that you can have a reproducible environment. If someone comes to your code base and wants to install your project, they are just going to run the migrations and they're going to have the database at the same state as you. That is the power of migrations. Okay, so this is the last configuration part, which is the generation for Go. This is the name of the package, which we need to change to repo. So I'm just going to call this repository or repo for short. This is the out package, so where it's going to generate this code. I want to generate this into the internal, so inside of this guy internal. Then I'm going to create a folder called adapters. And it's inside of these adapters that we're going to have our sqlc generated. Or even better, I'm going to actually create another folder called Postgres SQL. And inside of here, it's actually going to have another folder called the migration. So bear with me. This is going to make sense in a bit. You can even simplify this. This is up to you. Honestly, you can skip the Postgres and just add the migrations folder. I'm going to add here another folder on the Postgres level called sqlc. And if you want to get the code of this project, I'm going to leave the link on the description. So you don't need to actually type this out. I'm going to leave it there. And it is inside of this folder that we're actually going to have the Go generated code. So it's going to be internal /adapters /Postgres /sqlc. This is going to be the driver, the Postgres driver that we're going to use. This is the recommended one, they say. So I'm going to use this one. I'm going to also add some tags called emit JSON tags to true. And then I'm going to do the emit interface to true. This basically means that it's going to generate a query or a query interface that we're going to use to pass in our dependencies. If you want to keep doing dependency injection in your tests, this is important because they are actually going to generate interfaces for you. And then, last but not least, I'm going to specify here the queries to actually be inside of the /internal /adapters Postgres, and then it's going to be the migrations folder. So this is going to be a folder, and sqlc knows how to read from these migrations folder that we're going to use to, one, create a reproducible state on our machine, and then second, for sqlc to actually know the structure or the entities of our database. So they are going to know how a product and how an order is going to be made because they are going to parse this folder and they're going to read it. It's very, very cool that they do that. And again, if this is kind of confusing to you, it means that it's your first time doing this, and it's normal. The more you do this, the more you're going to understand how this is good and how it's going to save your life, or at least make it easier. But yeah, on my channel, I create projects a bit more simpler than this. Then we actually don't do sqlc. We actually write the queries inside of Go. And yeah, it can be messy at first, but at least you understand how it's made behind the scenes. This is kind of an abstraction of that, but it's very important if you want to build a production API. And again, from the beginning, I said this was going to be a production API, and this is what I would use. So there we go. Let's just finish up this. So this is going to be the schema. It's going to be on internal adapters. Let me actually just copy this instead, because this is going to be inside of the sqlc, and then inside it's going to be a file called queries.sql. I'm just going to create it already here, queries.sql. And yeah, if you come to your terminal and you type sqlc generate, I think, I'm not sure if they're going to generate or if you're going to go at an error. Error query parsing, so no queries. So yeah, we get an error because there's nothing here, so it makes sense. Let's actually start back to the queries, and then let's go to the migrations, because the migrations, we're going to use another package to create migrations and manage that. So let's just create a query. For example, from the documentation, let me actually just copy this one. So let's get, for example, the list authors. I'm going to copy this. The only syntax you really need to know is that you need to have this comment here with the name of the function. So for us, it's going to be lists. We could call this list products, and then this is going to be select all from products, and we can actually just keep it as it is, save this, and this is going to be our first query. Okay, you can, for example, create another query to, let's create another one already, to find product by ID. This is going to return at least one. This is basically to say that, hey, is this going to be an array? Is it going to be not? This is the way you tell sqlc to actually create the code, if this is going to expect multiple or just one, because hey, they could maybe know that from reading, but yeah, I think there's being a bit more explicit, I think it's better at least. So let's do this query. So select all from products where ID is going to be equal to an argument. So this is the first argument you send. If you have another argument, you just do it like this. And if you don't know SQL, it's completely fine. Honestly, just take a crash course on SQL, or just honestly ask AI to write to SQL these days, SQL has been such a low barrier language that it just everyone can write it. So I'm not going to focus much on that. If you want to become a backend engineer, you should know SQL at least. It's the minimum. Okay, with this created, the last missing part is that we actually need to have a package or a solution to handle our migrations. Usually migrations are done with, there's a couple of packages you can do this with Go. I wouldn't recommend you doing it manually because it means that you'd have to write your own CLI to run these migrations. Migrations have state. And yeah, so one of the packages I have been using recently is called Goose. There's another one which I have used a long time, which is the Go Migrator, but I think most people use this one now because it's easier to install, I guess. So it's a pretty cool package. This is how you install it. If you are using Mac, you can also use brew install. This is how I actually did it. Once you have it installed, check. I'm going to leave again all of these on the description, or even on the project. If you go to the description to the source code, I'm going to leave a .readme file here. I'm going to actually fill this up in a bit, which is going to have all of the links to install the project on your machine. But yeah, get this package. Once you have it, let's just run this command. For example, I'm going to actually use this guy here with the S flag, which means that it's going to generate a migration with this number instead of the current date. So I'm going to copy these commands. And then I'm going to paste it in. I'm just going to change here the migration. So I'm going to do a goose create, and I'm going to say create products. So this is going to be the migration we're going to use to create the products table. There we go. We have just created it. It's here on the root. We can actually just move this inside of the migrations folder. And this is where we are actually going to write our up migration and the down. The up basically means what we're going to change. The down is kind of a rollback. How do we revert this change on the database? Very important. If you mess up, you can always roll back as long as you write your down statements. So let's actually write our table. So we're going to do a create table if exists. So I always like to prefix this, or if not exists, products, and then this is the definition. If you remember from the diagram, we're going to have an ID, which is going to be a big serial. This is going to be also the primary key. So you don't need to be typing off this SQL. Get it from the source code if you want. I'm going to explain it either way. The name is going to be maybe a varchar, or actually I'm going to put it as a text. I don't want to be putting, I would put it as a varchar, but I don't want to go that route, because if you want to have a big name, I'm not going to worry about that. I'm just going to put it a text. The price in cents is going to be an integer. It's not going to be nullable, so it's not null. And then we're going to do a check inline, so kind of a business rule inside of the database, which is going to be the price in cents needs to be bigger than 0. So we don't have negative prices. It doesn't make sense. We don't allow that in our database. It's a good principle to do. And then just going to have the quantity, which is an integer as well. We could actually do not nullable. It doesn't make sense to have nullable quantities, and the default is 0. You can also have this rule if you want to have negative quantities or do not have negative quantities. I'll leave that up to you. Last but not least, we actually need to do this commas at the end. And last but not least, I'm going to have the created at timestamp with the time zone at the end. So it's timestamp, and then we just add time zone kind of T and Z. It's the name of the type, not null, and then I'm going to default this to now. I think this is how we do it in Postgres. I'll mostly use MySQL lately, so I might be mixing up syntax, but let's see. This is how we create the table. The down migration is going to be very simple, so just going to drop table if exists the products. Okay, so if you want to revert this migration, you just run this guy. If you want to create it, you just run this. Okay, so we have actually this created. Let's actually run the sqlc generate. We actually got the syntax error at the queries. Yeah, we have here a space. This is what my VS Code formatter is doing for some reason. So I need to be careful when formatting. Let's run this again. We still have some errors, so no queries contained in this folder. Oh, I see. I'm so blind. This is completely reversed. So the queries is actually this property here. Okay. And then the schema is this one. Sorry, guys, I messed up this. It's the reverse. So this is the schema. This is the queries, because the queries, yeah, it makes sense, right? Sorry about that. Let's run sqlc generate. No errors. And we can see that we have code generated here on this folder, which is from sqlc generating. This is our entity, the product entity. It's already here. It's everything created for us that we don't need to do. The query interface. So you don't change this file. It's commented here. You don't change it. If you want to change code, you actually come here to the queries and you type it here, or your migrations, which in this case, you actually create a new migration if you want to change something like this. So you can see that we have some errors because we actually need to import the drivers. So I'm going to actually, I'm not sure why I cannot import from here. I got this error before. What I'm going to do is that you can do a go get the name of this package, install it. There we go. And now the errors should be gone. This is actually the driver that you're going to use to create or to connect to a Postgres database. Okay, let me just close everything because there's a lot of things open. Because the last thing we need to do on this module is actually run a Postgres database locally. I'm going to show you how to do that. We're going to use Docker Compose for that. So I'm going to create a file called Docker Compose.yaml, again, configuration has code. And this is the place where I tell you, I don't know by heart the Docker Compose configuration, and I don't think most people know. So what I usually do is that I go for copy and pasting other projects that I have done in the past, or you can actually just come here to AI and ask it to do it for you. I have just copy pasted from another project. This is pretty much the minimal syntax you can go with for creating. So this is the services, the Postgres service that I'm going to create. It's going to use this image, the container name. This is the environment variables that I'm going to use for the local environment. So the user of the Postgres is just Postgres, the password the same. So not much secure, but it's fine because this is just for our local machine. The name of the database, and this is a durable container for us to store our data. Okay, so copy and paste this or just type it out. I'm going to test if this works by doing a docker compose dash, or in this case, space up. Let's run. I think I already have another one running, so let me do a docker compose down. Okay, there we go. It's starting. I just had to delete the container that I had running with Postgres. So there we go. It is running. We have a Postgres database running with Docker on our machine, as easy as you can get. For this, you basically need to have Docker installed on your machine. Docker for desktop. I have Docker for desktop for Mac. There's a one for Windows as well. So install that one if you don't have it already. What I'm going to do now is connect to that database from our application. So let's go to main.go. This is where we actually do the compositions, the connections, all of that. This is kind of the orchestrator. This is where we're going to connect to the database. So just before the application, let's do database here, where we're going to actually connect to that Postgres database. This could be a database from our local Docker container or even on the cloud. And this is where the power of configuration comes in. So we're going to create some configuration. And for now, I'm just going to hard code it. So it's going to be, let me actually come back here to the Goose documentation, to the sqlc documentation to see if they have, yeah, they have here codes. This is the connection string, how we do it. Let me actually copy this code. I'm going to paste it here. This is the connection string that we're going to use. So it's going to be from config.database.dsn. And this is going to be our DSN, which is this guy, which we just need to change the data because our Postgres user is actually different. It's the Postgres. I'm going to replace this. We have a password that we are connecting with. So I'm going to pass in the passwords. Database name is actually called ecom. And we're going to put the SSL mode as disabled for now. And last but not least, I think we need to specify the hosts, which is going to be a local host. And this is pretty much it. Now, Of course, once you are deploying this to production, you're not going to use this string. It's going to be a different one. So we actually need to get into environment variables. Let me show you how you can actually do or inject environment variables in a reusable way. So what I'm going to do is that I'm going to create a package on the internal called env. This is kind of a package that I always have on all of my projects. There are packages that do this, but I like to build it myself. It's pretty easy. What I want to do is just have a function that does a get string. This is going to have a key and a fallback value has a string. This is going to return a string. Basically, what I want to do is that I'm going to use the os.getEnv. This is how you get an environment variable, by the way, just this os.getEnv. But I like to create a function because if this variable does not exist, I like to send in a fallback. This is good for development because, as you're going to see, if this value does indeed exist, so it's different than an empty string, we're just going to return the value. Otherwise, I'm going to return the fallback as it is. Let me show you how we're going to use this. So I'm going to call env.getString. I'm going to pass in the name of the variable. And then this guy right here is going to be the fallback. Why I like to have fallbacks? It means that I don't actually have to specify any environment variable if you guys are running this on your machine. I'm going to call this variable, for example, goose_db string. Okay. This is going to be a variable that we're going to have to define in just a bit to run our migrations, which we actually haven't. Our database is completely empty as of now. If we were to run our application, it would connect, but it would fail once we are, for example, fetching products because that table is not yet created on the database. The migrations are not yet run because we have not connected to the database and run them it. But first, let's just focus on connecting our API to the database. So this is the default string. This is the variable. So if this variable does not exist on our .env file, okay, if this variable does not exist, which it's not going to exist, I'm not going to load them. If you want, there's a package from Go called go.env. This is right here. Look it up. This is how you can install or load variables into your package. But yeah, if it doesn't exist, it's going to use this fallback. But I'm going to copy this fallback like so, and I'm going to paste it here. This is going to be my, actually I need to put this with strings, just like so. Since we're here, let's actually define another variable called goose driver. This is going to be Postgres. So we're just telling Goose, our migrator, that our driver is Postgres. And last but not least, let's tell Goose where our migrations are. So goose_migrations dir, or actually migration dir. I'm getting these variables from documentation, so don't worry, I'm not making this up. These are actually from Goose documentation. You can look them up there. And this is the directory of our folder. So it is internal / I'm going to actually just copy it like this. So copy relative path. There we go. And this is the path of our migrations. Okay, so we are almost there. Let's actually just pass in our context. So I'm going to create a global or top level context here. So it's a context.background. This is kind of the top level context you can create. Pass it in here. We already have defined our domain string. And then if there is an error, I'm going to actually do an os.exit like we did below. And I'm actually just going to copy this here. Actually, we can just do a panic, honestly, with the error because we actually have the logger defined down below. Maybe it would be a good idea to paste this below here, but hey, and since we are panicking, we don't need to do this. True, let's remove that. I'm going to defer the connection close. So if something happens, I'm going to use the defer keyword in Go, which means that this is going to run once the function exits. And then I'm gonna move the logger before the database because I actually want to log something. I just like to see that the database has been connected. So I'm gonna do connected to database and then I'm going to pass in the domain string, which is this one right here. Okay, so once we start the server, we should see this log and the log of the API running. Yeah, let's actually test this out on another terminal. I'm going to do go run main.go. So you can see that we actually got an error connecting to our database. I know exactly why. It's because of this. So I actually mistyped this. It is not disable. It's disable, not disabled. I'm going to actually change it here on the env as well. So sorry about that. It's disable. Let's run this again. There we go. You can see that connecting to the database. This is the string, and here is our API. Now, the last thing we actually need to do is connect to our database. This is, of course, optional, but I'm going to show you that I'm using a tool called Table Plus, which is basically an editor to connect to your database. So I'm going to right-click on the table editor. There's multiple programs that do this, but if you want to install Table Plus, it's free. I'm going to create a connection, and I'm going to select Postgres. Here is the connection that we need to do. So I'm going to just call this local. You can write anything you want here. And then your user is going to be Postgres, password, Postgres, and the database, you can just type it ecom. So the exact name we have on our configuration string, so database name, user, host, all of that. I'm going to test the connection. It's green, it works. I'm going to just save and connect to it. I'm going to select here the database at the top, to ecom, and as you can see, we currently don't have any tables whatsoever because we have not run the migrations. Let's run the migrations. This is the last step, I promise. Let me come here to new terminal. Or actually, we can reuse this one. I'm going to do Goose app. This is all you should do to run the migrations with Goose. There you go. No errors. That's nice to see. This is the version of the database, version 1. If you go back to your terminal, to your Table Plus or whatever tool you're using, refresh, you can see that we have one table created called GooseDB version. This is what Goose has created to keep track of what migrations have been run and which migrations have not. And then we have our product table. I actually cannot increase the font for you guys, so sorry about that. It doesn't allow me to do here. But you can see that we have the products table that we have exactly defined in our migrations. If you want, you can do goose down. This is going to take down the table, and then you do goose up again, you're going to be able to get it again. So this is how migrations work in a nutshell. Okay, so far we have created pretty much the whole structure for the API. We have touched on pretty much everything. The last thing missing is actually the business logic, and we basically left on creating the products. So here on the service, we actually need to fetch the products from the database, which now we have. So yay, we can continue this part. So let's finish up by listing the products, and then basically the next module is going to be as creating the order endpoint. So that order endpoint, we're going to touch on transactions and some pretty cool things that you need to build this robust endpoint and API. Okay, so the products is pretty simple. What we're going to do is that now we can actually fetch the products from the s.repo. We don't have access to this yet. We actually need to pass this dependency. Remember, I left these comments for us to add the repo.queries, or even better, you can actually do the querier, which is an interface. Always prefer sending interfaces instead of concrete implementations. So we're going to use that. And then I'm going to pass in a repo.querier, just like so. I think we can just do this, but I usually do it like so. So let's keep that away. And here we have automatically two methods created for us from sqlc. So very cool. We have the list products, which we're going to use. Let's pass in our context. And this is pretty much it. Let's handle the error. Or even better, we can actually just at all return this, because this is all we need to do. If you want to handle the error, you handle it on the parent. Let me actually, because now that we have the list products, we can actually use the product entity to return here on the, remember I said we needed to actually have here the entity. Now we do. So let's do a slice of repo.products. and an error, which means that we can actually just copy this and change our implementation to work. There we go. And now our handler actually has products to use instead of the hard-coded products I have been using. Let me save, and just with this simple change, we are now fetching products from the database. How clean is this transition? I don't know, man, pretty good. The last thing we actually need here is the service needs a query. What is a query? It's just the database.config, or in this case, app.db. Oh, I actually have not defined it yet. True, I have not defined the db here, so nice thing. I forgot this part. So we actually have the database on the application that we create here on the main, but we have not yet passed this connection to the application here. So I'm going to just do this. What is this? This is a pointer to pgx.conf, so the driver v5. Let me actually do it right. So save it. Let me see if it's the right import. It is this one. It is correct. And now we can actually call. I just remembered that we actually need to call the repo.new, send our database with transaction. Good, very good detail. We're going to use later on the next module. Let's save this and let's restart our API, because right now we can actually fetch products from the database. So let's actually test this out. Let me go to Postman. Let me hit send, and we're going to get null because we don't have any products. But if you go to the database and manually add the product, so we can omit the ID. It's going to be auto-generated by the database. The product could be, for example, a MacBook Pro M1. I don't know, my machine. It's going to be like 200 cents, or I don't know, whatever unit you want to keep here. The quantity, let's keep 20. That create that. I think it's going to be auto-filled as well. There we go. I'm going to create another product, for example, AirPods Pro, and then the price is going to be like 600. I'm just going to have 3 units. Let's save 3 units in stock. Now let's actually fetch the products again. And as you can see, we're getting them all from the database dynamically. Pretty cool, eh? Now we can basically start working on the other handlers. Now the thing is, pretty much what we have that I wanted to teach you, I have already done. So you know how to create the handlers, the services, you know how to structure. Whatever else we're going to do now, it's going to be pretty much copy paste, except I'm going to teach you how to do transactions on the next module. But I want you to actually stop the video now, and as a challenge, try to implement this method here, the get product by ID. So we have already done this right now, the get products, yet we have not implemented the query parameters. I think we're going to have to do this in a different lesson, because this is already getting huge enough. Try and build this endpoint here, which is basically the same, the slash product, but filter it out by an ID, which basically means that you're going to have to reuse, and I have already done that for you actually, which is you're going to have to use the find product by ID, create a new handler here, so create a new function, for example, find products, and then you're going to have to do the correct calling of the functions. And of course, you actually need to define here the signature. Okay, so I'm not going to do that. Do that as a challenge if you want. I'm going to move on to the next module, which is we're going to work on orders. So we're going to work on the big endpoint, which is this one, the placing an order, because this the thing is, how we're going to place an order is going to be important. So a user is going to come in, he's going to place an order. For example, this is going to be the customer ID. If you have authentication, this is going to come from authentication from the token, not from the parameters, but we don't have authentication. So for now, it's going to be on the payload. And then the most important part is actually the items array. This is going to be kind of the cart, you could say, that you have on your application, or for example, Amazon or whatever. This is the product ID, and then the quantity or the amount of items you have of these products. This way you can select how many we want of what we want. I think that makes sense. And then very important thing to say, if you are on an interview, this is kind of the golden part I would be looking for, which is the API is going to save those order items, the quantity and the current price on this table. So this way we can actually handle if the item was sold at a discounted price. So remember what I mentioned at the start, that we have this order table that we have to create with the orders. The order is kind of like the header of the receipt, you could say. It has the ID, the customer ID, when it was created, all good. But the metadata is on a different table, which is going to be the relationship between the product, the order itself, and the quantity and the price it was sold at. Okay, so this price is here of this product, but we're actually going to duplicate it because it might have been sold at a different price. Very important to note. I mean, there could be better approaches to this, but I think this is a very simple one to do to solve this problem. So I'm going to create a new migration. If you remember how to do it, it's goose-s create. I'm going to do create orders. There we go. It actually created inside of this folder now because we actually specified the folder with this variable, and Goose, the CLI, is going to read this variable and it's going to respect that. Now, to save you some time, I have already typed everything. Of course, you can get this from the source code, but basically this is the definition on the diagram of what we wrote there. So we have an orders. Actually, this is now like so. And this is going to be the order items. Okay, so I'm going to do a goose app. There we go. We have run our migrations. I'm going to do an sqlc generate just for sqlc to know that, hey, there are new models, the order and the order item. So awesome. And now let's actually start from top to bottom. I'm going to create the handler signature for this. So it's going to be a router.post. So the first post method we have /order or even orders. You could keep the plural syntax like we have. And then the handler is going to be the orders handler dot place order. We need to create this handler and this method. So I'm going to just do, for example, here like orders dot new handler. I'm going to keep the service as nil. So let's actually create this folder. Let me close everything. Internal, we have the products. Let's actually create a new folder for orders. So let's keep everything separated. Again, the same clean architecture structure with the handlers, or even handlers. This is how we actually called it. Handlers, yeah. Service.go. And by the way, if you want, pause the video here. Try to implement this everything from scratch because I think it's a good challenge. Even if you don't nail it, I think it's a good thing that you try to implement this yourself. So actually go ahead and do that. Don't forget that you need to go to your adapters and actually create a new query here. But yeah, if not, I'm going to continue. So this is going to be on the package orders, just like the handlers. And now I'm going to pretty much move a bit faster because we're getting this video huge. So I'm going to type it out. It's basically, I'm going to copy and paste from handlers here. I'm just going to change the names and the dependencies, and then I'm going to show you what I did. Okay, so there we go. Pretty simple. What we have just done the same on the products handler. So the handler struct with the service has the dependency. I'm having a constructor and then our place order method. And I'm just returning the JSON with the status created and nil has the output. Okay, so nothing fancy so far. Let me go to the service now. Let's actually do the same here. So I'm going to kind of copy paste what we have here. There we go. So the same, we get the service struct and we have a constructor. I'm actually omitting here the interface so that we can move a bit faster. But if you want, you can write the interface for this place order. And speaking of it, it is the method that we're calling here on the API.com. This is, let me actually import this guy that we have. There we go. It's this place order, which we are going to, actually it's the service here, that we're going to have to pass some payloads. What is this payload? This is going to be pretty much this guy right here. So the customer ID and items that we're going to send in our JSON payloads. I'm going to create here a new file called types.go inside of the same package. And this is basically the payload that we're going to go for. So this is going to be the customer ID. This is the JSON signatures. So the marshalling of JSON. This is the items, which is the size of order items, which is the product and the quantity. So basically this guy right here inside of the array. Okay, so this is an exact match of what we wrote there. Last but not least, I have just typed here the service interface so that we actually have it. I said I wasn't going to do it, but yeah, let's just add it for consistency, and we're also using it here, so it's a good thing to do. So before we actually start working on the algorithm for placing an order, this is where we're going to actually make the transaction. Let's just finish the handler because this is easy and you already know how to do it. So what we need to do, just call this service. So we're going to do h.service.placeOrder. Let's pass in the request.context. And then this is going to be the temp order that we're going to receive from the payload. So what we're going to do is that we need to read JSON from the body. So for example, if you go to Postman and you do a post request, you actually can go here to the body, raw, and then you can select JSON as the payload. So this is data that is sent on your request to the server. So you can, for example, say, hey, I want the customer ID 42 with the custom item. So this is a slice of the item ID or the product ID. I think this is how we're going for example, the ID 1. And we want, for example, one of these item. Okay. When you hit send, this is going to be received on your server, but first you need to parse this because this comes from the request.body, which is actually an IO reader. So we need to actually read from the body. And the way we're going to do that is that we're going to go to our JSON package and let's create a reusable read function that is going to receive the request to pointer.http.request. This is pretty much this guy right here. Okay. We're going to use this guy, and then we're going to, oops, I deleted this. And then we're going to copy this data to a struct, which is going to be data, which could be anything. We don't know what it is. And then let's get a decoder, which is going to be a JSON.new decoder. Let's send our body. This is how we're going to get a JSON decoder from the body. And with this guy, we can actually do just a return decoder.decodes and the data. Why did I do this into a different variable? Because I like to actually call the disallow unknown fields. This means that if you send, for example, a different property like user ID or I don't know, potato, this is going to throw an error. I like to keep my APIs very strict because of this. So I'm going to do this. This might actually save you from malicious attempts to your database that you might not even know. So keep this property in. And now that we have that read, I'm going to actually do inline JSON.read request or just a request. And then we actually need a variable to place that data in. So this is a pointer to temp order. I'm going to define it here. So temp order has a create order params. I'm going to handle the error in line. If we have one, I'm going to return. I'm going to also log it so that we know what is going on and return to the user an error with a bad request. So this is a different status code. It's a 400. It means that the user has typed a wrong payload. So it's actually a user error from the payload. You can actually click these links and you can understand what each of these codes means, but with time you get to understand what they mean. Now that we have the place order, we can actually get the created order and an error. I'm going to handle this error the same. So I'm going to actually copy and paste these, change the code to be internal server error, and then return the created order to the user. This is all we need to do on the handler. If you create another handler, this is pretty much the same pattern. You read the payloads, you call the service, you return to the user the payloads with the status code. HTTP handler, this is the transport layer. Let's finish this whole course by finishing up the service. Okay, now let's start working on the transaction and actually finishing up the place order functionality. So before we actually get to transactions, let's do something that we need to do here, which is payload validation. Now we could very well do that on the handlers, and I actually like to do this on the handlers, but there's something here that is very specific, which is I want to check if the items do exist on a database. For example, you might request an item ID or a product ID that does not exist. So I want to check that in all one place, and kind of the way that I'm going to write this algorithm, it's going to be more performant because I'm going to do everything in line. So I'm going to assume that everything is correct. So we're going to create an order, right? We're going to create the order, even if the products do not exist. All of this because we're creating a transaction. So if the product does not exist, so we're going to create or look for the product if exists. If the product does not exist, we can roll back the transaction, throw an error, and the order is removed. That's the power of transactions. And then we're going to create, if they do exist indeed, create the order item on the database. Okay, so this is kind of the algorithm. I think it's kind of the best worlds between performance and readability. So the first thing actually we can do is validate some basic things on the payload. Again, you could move this to the handlers. Since I'm here, I'm going to do it here. It's fine, which is temp order dot customer ID needs to be, it cannot be empty. It cannot be 0. So the empty value of an integer in Go is 0. The empty value of a string is empty string. So this is what an empty value means. If it's 0, we can just return a repo.order, so an empty one, and then an error, which is fmt.error_f. This is one way to create errors. For example, customer ID is required. This is important. And then you can, for example, say, hey, if the length of the temp order.items is 0, we can say, for example, let me copy this. We can say, for example, at least one item is required. Okay, so we can say this. Let me actually at least, there we go. This means that, hey, let's not create orders without items. Let's not do that. This is mandatory. So let's actually focus now on the algorithm. And here we actually need to create a transaction. Okay, so let's look at how you can do this in sqlc, because it's different package from package, but the idea is the same, because all packages, even the ORMs like GORM, all of them depend on the Golang database /SQL. This is the main driver of everything. And this is kind of the transaction of a DBTX. So this is kind of a name that you might see around. This is kind of a database driver that is able to do transactions. So the way that we actually do this is, you can see that you can do db.begin. Where is it? Actually, we're using this driver, so we need to look at this guy. So create a transaction like this. We're going to roll it back. So I'm just going to copy this part here. I'm going to explain to you what it means. Let me actually put it here, because we actually need to do some more imports. We actually need a database connection. So let's come here to the service struct. And I'm going to add a new thing called db. And it's going to be the pgx.con. So this is our connection that we have already specified on the app. So we already have access to this. I'm going to actually copy this, do this on the second parameter, because we need this for the transaction, unfortunately. So let's get this. And basically, we don't return an error. Instead, what we do is that we return the empty order and an error like so. So I'm just going to send in the original error from the transaction to error. And this guy here is actually what creates the transaction. With this, we're going to use this type, the pgx.transaction, to actually make our query. So you can see that we're going to roll back. If anything throws an error, if this function fails, we're going to actually call this at the end. So this is kind of our fail-safe mechanism. And then we're going to actually, instead of using the queries, we use the s.repo. This is basically the way we're going to organize. And this is kind of our repo with a transaction wrapper around it. This is kind of what it's going to do. And this is how we're going to create or communicate with our repository layer. So let's create an order before we actually go here to the API and send in our new dependencies. let's just focus on creating this algorithm and then we go there. So first is an order. So let's create the order, which we actually need to create that on our queries.sql. So if you do this, you're going to see that you didn't have anything related to orders. Let's actually fix that. Let's go here to queries and let's create our order creation. So let me actually type this with you. So create order. This is going to return one item. So insert into orders. So this is the orders table, which we already have on our database. We have run the migration, I think. So let's do the customer ID. So we want to insert the customer ID as well as the created ads, which actually we can leave it empty because it's going to be the default one. So let's leave that empty. Values. Let's send the first argument only, and let's return, or we're using the returning all in case we want to return everything and consume that. Okay, this is the first query, and the last query we're going to do for this course, it's going to be the create order item. This is not going to, it is actually going to return one as well. What this is going to do is that here, as you saw, we will create the order, and then we're going to create or attach the items to this order on the order table. So it's going to be an insert as well into order items values, or actually we need to specify what we want to insert, the order ID, the product ID, the quantity, and last but not least, the price in the price, not price, price in cents. Let me actually double check if this is the actual name. I might have written Prince. No, I have not written Prince. Or actually, this is price cents. So hey, this is actually in cents. I'm just gonna use it price cents. I don't want to be rolling back this migration and then running it again. So I'm just gonna roll back, roll out with the price cents like this. I'm fine with that. At least you can still understand what this means. I'm gonna return, or actually I'm gonna use the values 1, 2, so we need 1, 2, 3, 4, so we need 4 arguments for this. There we go. And then I'm gonna just say returning everything. And by the end, we need to also add this semicolon to be valid SQL syntax. Okay, let's save these queries. And now if you do sqlc generate, there we go. It didn't throw any errors. I'm gonna actually do goes up to see if we have any migrations. We don't, so I have run it. I didn't remember that. But hey, we have here the transaction query, but now with the create order and the create order item. So let's create an order. Where do we have a context? I'm gonna actually just say context is gonna be the request dot, or actually we have it from the parameter, sorry. We actually have it here. So I'm just gonna pass context. The customer ID is gonna be the temp order dot customer ID. This is all we need to create an order. It's just the customer ID. And now that we have an order, we can check if there is an error. So let me do that check really quick. If there is one, I'm gonna just return the repo order and then an error, and then now let the handler handle this error. Okay, so all of this is inside of the transaction. So if you get here, we're gonna roll back. Now we need to actually look if the products exist. So all of the products inside of our order, and if they do exist, we're gonna create them one by one. Okay, so let's create a loop. So I'm gonna loop from all of the items. So I'm gonna range do temp order dot items. Okay, and then I'm gonna do a product error because I'm gonna actually get the repo dot find product by ID. So we have already built this before, so we're gonna use this. This is the same method you should have used for that challenge I mentioned to create the get by product ID. So we're gonna reuse this repository method. We're gonna pass in the product ID as well. So we're gonna look for it if it does exist. If it doesn't exist though, I'm going to return the repo.order. So hey, there's no order, and then I'm gonna return an error. So I'm gonna say error product not found. Now the reason I'm gonna create an error like this in a variable, it's because if we want to do some error matching on the handler, for example, if this error, we can return a 404. If this error, we can return another code. So this is why I'm gonna do it like this. So using the errors package dot new and I'm going to say product not found. Okay, let's reuse this error like this. And this is basically what you can do after that. Is you can, I'm just going to show you here really quick. For example, if the error is this error, you can actually do this. So you have a status not found. You can actually do this. This works as well, as long as we save this file. Yeah, this works. Okay. This is kind of what I wanted to show you by creating an error as a constant. So now you know. Now here, if we are here at design, it means that the product does exist, but there might be another problem, which is if the product dot quantity, so if there is no stock, so if you are requesting less quantity than we want, hey, we need to also return another error, which I'm going to actually create another one, which is products no stock. Okay, just like so. You can handle this error like you want. I'm just going to omit it for now. And last but not least, we need to just create the order item. So let's do this. So if don't forget to actually do all of this. Actually, we should do like so. I actually almost forgot that. We need to use, actually in this case, it was fine to leave it like this. But since we are inside the transaction, let's always use the transaction query. Very important, because if you don't use the transaction query, there's going to be products that might not exist at this point, and then the order rollback is not going to work properly. So make sure that you're using the query transaction. And here we can just, what do we need? We need the order ID. So we already have this created. So there we go. The product ID is this item at product ID. The quantity, it's the item.quantity. So here we are already creating it. And then the price in cents is going to be the price at which we bought this product. So it's going to be the product dot price in cents. I think we have price in centers. Why? I actually have this price in centers and not cents. Where did this came from? Oh, it's here. Well, I actually typed this price in centers. So the way I would go about fixing it is that I would create a new migration and I would alter this table with a new name. And then, yeah, I'm not going to fix it for now, but if you want, create a new migration. Probably you didn't have this error because you saw it before me probably, but if you didn't, create a new migration, fix it. I'm going to move on. I think that is fine for now. So we have this error. It's because of this. There we go. I'm just going to copy this error handling here. Actually, that's not an error handling. So let me do return an empty order if there is an error. So if for some reason the order item didn't create, I'm just going to pass in the original error. And at the end, I'm going to return the actual order and a nil error. And this, my friend, is the whole algorithm to create an order securely. Okay. So there's more things we could worry about, but for now, this is covering 99% of cases that an interviewer might throw at you. This is pretty good, in my opinion. So let's actually see here on the handler, we are consuming the place order. There we go. What's missing is here on the API. We need to update our handler to receive a service. So let's actually create our orders or order service, which is going to be orders.new service. This is going to receive the repo.new app.db. It's the same as this one, so you can actually make these into constants and reuse it. And then the second one is going to be the app.db. And here, I think you need to wrap in a constructor, or no, it's just, yeah, they just want a connection. So let's use the connection. Let's send it to the handler. Let's save. And there we go. This is pretty much it. We have the orders created. Let me just double check if we're missing something. We're parsing the payload, or marshalling the payload, I should say, placing the order, and then the place order is going to be this service right here. Now, before we actually test, there's one thing that I almost missed, which is when we create a transaction, we actually need to close that transaction. And this is not it. This is a rollback. We actually need to commit the transaction. So we need to call the transaction.commit with the context, and only now this is going to actually commit the transaction. Okay. So if you did not do this, you would be creating orders and they would not be saved on the database. Okay. That's what would happen. There's this one thing that we actually need to do if you want to take this as a challenge, which is we are going to create items, we're going to create orders, but we are not going to decrease the stock. So what you might want to do is that after this, you might, for example, update the product. So as a challenge, update the product's stock quantity with the one we requested, so that the next order we make, it's going to use the updated stock. Okay, so take this as a challenge if you want, because we're just going to wrap up. I'm going to restart the API and I'm going to show you everything running. Okay, so let's come back to the Postman. I'm going to hit send. So actually, let me put these. So I'm going to go to /orders. I'm going to use a product that does not exist. I'm going to hit send. We got this error, so product not found. We're doing the error matching correctly. Awesome. Let's actually request for the item 2, which is the AirPods. So here we go into products. We have this AirPods product ID 2. You just have 3. So I'm going to request 5. We should have an error. There we go. Let me actually make this working now. Let's request 2. And there you go. We have an order ID 6 for this customer, and it was created at this date. Let's see the database. Here we have the order created and the order items are all here. So this is pretty much the whole flow that I wanted to show you and the whole project. Hopefully you enjoyed. There's still a couple things more to do, and I made these in purpose so that you can actually practice. So the first one is that we should have already built this. So this was one of the first challenges, to build this endpoint. The second one is you can actually build now a post for the product. Let me actually remove these drawings here. They are confusing. There you go. You could actually work on this post. This is another endpoint, very similar to the orders, but you'd create a product. So very simple, not much validation. And then you could actually work on this one. This is interesting, which is getting a single order. So after you made an order, you could, for example, fetch this order by ID, which in turn you need to go to this orders item and fetch all of the products and do a left join on the product table. So this is a bit more SQL intensive, but it's a pretty nice exercise. Go ahead, give it a try. If you are stuck, you can always ask ChatGPT, or even here in the comments, I can help you, or you can go to our Discord server as well, which would be more than happy to help you. So hopefully you have enjoyed it so far.